Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about trigonometry. Now the question we're going through here is 2018 Paper 2 Question 4. And the first part of this question was a unit circle question. Now this is always an area of contention with students, so there's loads of methods doing this. So if you do this method differently to me and you're getting the right answer, then that's fine. So this is just the way that I teach my students, so if you're doing it differently, that's fine as long as you're getting the right answer. In this case, you're told that cos 2x equals minus root 3 over 2. Now, if there's a number in front of the x, the first thing you should always do is double your domain. If you want x between 0 and 360, that means you want 2x between 0 and 270. So that means I'm going to go around the circle twice and I'm going to get 4 answers. The next thing I want to do is get my reference angle. I want to figure out, now to get your reference angle, you can ignore the sign. Treat it as if it's just root 3 over 2. And according to your log tables, when is the cos of an angle equal to root 3 over 2? If you go to page 13, it tells you that the cos of 30 degrees is root 3 over 2, so your reference angle is 30 degrees. Then you have to figure out which quadrants your answers should be in. So this is where you have to accommodate for the sign. When is the cos of an angle equal to a minus? Well, remember your ASTC. You know that cos is negative in the second quadrant and in the third quadrant, which means you want to get values between 90 and 180 and between 180 and 270. Now to get a value in the second quadrant, you imagine you always start there and you've done half of a revolution, so you're at 180 degrees. And you're going back into the second quadrant. So it's 180 minus your reference angle, which is 30 degrees. So your first value is 150 degrees. To get a value in the third quadrant, imagine you started at 0, you're at 180 and you're continuing on into the third quadrant, so it's 180 plus 30 degrees, which gives you 210. So there are all of your values between 0 and 360, but you need to continue on because you want to go between 0 and 720, so you need to get 2 more answers. So the next time, now there's a couple of ways of doing this as well, but you need to get a value in the second quadrant and the third quadrant on the second revolution. So I suppose you could view it as 0, 180, 360, and if you continue on, 360 and 120 degrees is 540. So in the second revolution, I'm at 540. And in the second quadrant, it's 540 minus, which gives me 510. And in the third quadrant, it's 540 plus, which gives me 570. So you've worked out 4 different values, but you've worked out values for 2x. You've worked out that 2x is equal to 150, 210, 510, and 570. But obviously you don't want 2x, you want x. So in order to get x on its own, you divide all of your values by 2. So your answers are 75 degrees, 105 degrees, 255 degrees, and 285 degrees. So your 4 answers there, and then notice that your 4 answers are within your original domain. Your original domain was all of the values need to be between 0 and 360, which they are. Okay, the second part of this question, we're told to let cos A equal to y over 2. We're asked to find the value of 2a in terms of y. Now there's something that's really important that I've highlighted over here. They've told you that a has to be between 0 and 90 degrees. Okay, so in other words, they're telling you that only the first quadrant is fair game in this question. It's nothing to do with your unit circle. It's nothing to do with the 4 quadrants. But really, in the vast majority of the time when they tell you that, it's a hint that at some point in this question, you're going to have to sketch a right angle triangle. Usually that's, if you're dealing with sine and cos, that's usually what a being between 0 and 90 means. Okay, so I want you to, from now on, when you see that in an exam question, think of a right angle triangle. So you've been asked to get sine 2a in terms of y. According to your log tables on page 14, the sine of 2a is equal to 2 times sine a cos a. So at the moment, I can nearly sub in for all of that. Right, 2 is just a number. The cos of a is equal to y over 2. So I just need to figure out what is the sine of a. Now, if you know the cos of a, you can work out the sine of a, and you can work out the tan of a. Because remember that remember the ratios. Cos represents the adjacent over the hypotenuse. If you know the ratio of the adjacent over the hypotenuse, you can work out the opposite. Remember, we want the opposite because the sine of an angle is the opposite over the hypotenuse. So with that in mind, we can use our sketch. If I label that as my angle A, I know that in the context of this question, the adjacent is y and the hypotenuse is 2. Now clearly adjacent to the angle A is this side and the hypotenuse is the one opposite the right angle. So I just need to work out what is the opposite. Let's call it x for the moment. I'm trying to let's call it O. Okay, so that's my opposite. In order to get the sine of A, I need the opposite over the hypotenuse. If you know two sides in a right angle triangle, you're just going to use Pythagoras' theorem. So if you sub into Pythagoras, you could say that y squared plus the opposite to be squared is equal to 2 squared. In other words, the opposite squared plus the adjacent squared equals the hypotenuse squared. So you end up with y squared plus the opposite squared is equal to 4. So if I isolate the opposite squared is 4 minus y squared. And obviously I want to get rid of the squared, so I get the square root of both sides. That means that the opposite in this triangle is the square root of 4 minus y squared. So now on my triangle, I can label this side. If that's a y and that's a 2, this must be 4 minus y squared. And remember, I'm happy enough to have a y in that because my answer needs to be in terms of y. So with that in mind, now I can easily get the sine of A because the sine is the opposite over the hypotenuse. So let's sub in now. Remember, we're looking for sine 2A, which is 2 sine A cos A. So I know what my 2 is. The sine of A is the opposite over the hypotenuse. The opposite in this case being the square root of 4 minus y squared over the hypotenuse, which is 2. And the cos of A is the adjacent over the hypotenuse. In this case, it was given to you in the question. It's the adjacent, which is y, over the hypotenuse, which is 2. And I want my answer in terms of y, so I'm happy enough with this. I just need to simplify it down a little bit. I have the 2 here and the 2 there will cancel out. Or the 2 on the top and the 2 divides into 2 once. And on the top line, I suppose you could just view this as you can multiply y by y times root 4 minus y squared. And on the bottom, all you're left with is 2. So your final answer there is just that the sine of 2a is equal to that. Okay? The thing I want you to take from this question is that usually, if they mention a being between 0 and 90 degrees, it usually means sketch yourself a right angle triangle. Not always, but just that would be a good thing to jump into your mind in the exam. So I hope this video made sense. If there's anything there you're unsure of, or you want me to clarify something, just let me know in class or send me an email and I'll try and clarify it for you.